Good morning, friends. I, Professor A.K.Chaubey, again do a problem. Professor Chaubey series class under the heading Physics Made Simplest. See, look, I have a problem here. The problem is very simple. What the problem is? I have a cube, a skeleton of the cube like this. A, B, C, D, E, F, G, H. This cube has got equal resistance in all the arms, say R. R resistance here, R resistance here, R resistance here, R resistance here, R here also, R here also, R everywhere there is R. So all this R also, this also R, this also, all each branch. So 12, say 1, 2, 3, 4, 4, 4, 8. And 9, 10, 11, 12. 12 branches of this cube, each has got resistance R. If we connect a EMF source between A and G here, we connect the source of EMF like this. Current is flowing. Now we want to find out what is the equivalent resistance between points diagonally opposite A and G. What is the resistance between A and G? This is the problem. Very simple looks, but complicated because we have so many branches, 12 branches, and we have to find out the equivalent resistance between A and G. So we have connected a voltage source E here between, say, this A and G, and now current is divided in all branches, and we have to find out the equivalent resistance between A and G. So what we do? Let me assume, say 6I, let current coming out from EMF source is 6I. I have taken current here, 6I, here. Then at this junction, there are 3 branches. So 2I, because equal resistance, so 2I current goes there, 2I current goes there, and 2I current goes there. So 6I current divided into 3 branches, 2I, 2I, 2I. When this 2I reaches here, there are 2 branches, equal resistances, so I goes there and I goes there. So in this branch there is current I, here is 2I, here I, here I. Similarly here 2I and here I. Similarly here 2I and here I. So this I reaches here and I comes from here. In this branch it becomes 2I. Similarly this I reaches here and I comes from here 2I, and so on. So similarly here also, this I goes there and this I comes here, it becomes 2I. So we know here current 2I, here current 2I, here current 2I, and so on. In this way we know current in all the branches, all the 12 branches, we know the current. So that way we have, say, loop. What loop we have here? A, E, F, G, A. A, E, F, G, A. A and we have A, B, C, D, E, F, G. So A, E, F, G, and then A. So this loop, A, E, F, G, and A, maybe from this side or this side, equal. So means we are having this loop, and for this loop we write the equation. We write the closed circuit Kirchhoff law, voltage law. Apply voltage law. Means voltage IR drop here and then apply voltage source must be equal, means impedance voltage and then voltage drop, or the summation of total is equal to 0, you can say. But you have to take into account the sign of plus minus. If this is plus, drop must be opposite. So that way we write the voltage equation. How we write? Say A E twice I into R. There is A E. E F is I into R. So that is this we are taking, say, clockwise. Clockwise current we are taking minus. So minus twice IR and minus IR, this is IR, and what else? This is twice. So A, E, F, G here. So twice I, R, IR, and this twice IR. So in this A, battery connected here. So this applied source. So this is the voltage law equation, that all the IR drops plus E must be 0. That is the no, for the conservation of energy, total energy supply and total drops. This must balance. Energy is not accumulated. So all E applied voltage must be equal to the IR. You can write like this. E is the applied voltage. This must be equal to IR drops. IR drops. What is I? Somewhere 2I, somewhere I. So applied voltage like this. So this you can solve now. 2IR, IR, 2IR, 2 to 4 plus 5, 5IR. So 5IR is equal to minus E. And that is what? Minus 5IR is equal to E. So what you get? 5 by, this is yeah, 5IR equal to E. So that means we are given the voltage here connected somewhere. No. So minus 5IR is equal. So 5IR is equal to E. Say equivalent resistance R. Let R be the equivalent resistance. Let R be the equivalent resistance between corners A and G. Then R is the equivalent resistance. Then what we have? Total current is 6I. So potential is 6I into, the potential is here. R is the resistance. So 6I into R. So potential is 6I into R. 6I is the current. So E is equal to 6I into R. Because 6I is the current taken here, R is the equivalent resistance. So this is the potential drop E. So we put it here. So that is now we have R is equal to here. This is 6I R. So 6I cancels. So R is equal to 6 by 5, because this is 6IR. So R is equal to equivalent resistance R. If small r is given, so we have to calculate capital R. R is equal to 5 by 6 of R. Each resistance R is given. We get the equivalent resistance R as 5 by 6 into R. This looks very complicated question, but it is very simple, because just you have to apply the Kirchhoff voltage law. So this gives the equivalent resistance between A and G, 5 by 6 R. There's many times this question has been asked in the examination, because it looks very complicated. So many 12 resistances are connected. But you must know the trick how to solve this. So you can solve similar problems, several problems. Okay, now I make another circuit and I try to solve that circuit. I have a simple circuit, say as given. I have here a resistance here or 2 ohm, that is a battery of 6 volt. So this is C and D. C point and D point. This is now here. Here I have the point E. And this is the F. And this is the here point B. Or I write here B, and then here H, and here also I have to connect something. Here I have to connect a resistance of 3 ohm and battery of 2 volt. This is say of 3 ohm. 2 batteries even need to be EMF 6 volt and 2 volt. They are connected and their internal resistances are, these are the internal resistances of the battery. Internal resistance. There is also internal resistance. Of the battery. Two batteries are connected like this. And this is point here is connected across a resistance of 5 ohm. This is 5 ohm. Point A and G. So I have this circuit. Say A, B, C, D, and oh, I have joined here. No. I have joined here. G. So A, B, C, D, E, G, E, and this F, H, a circuit given here. 2 batteries of 6 volt, internal resistance 2 ohm, 2 volt voltage and 3 ohm. They are connected in parallel and they are applying a voltage, this connected to a resistance 5 ohm. So calculate current through each battery. Calculate current through each battery what the current to each battery, and terminal voltage. Now what we do? We consider the loops here. Say we consider loops loop. Which loop? So consider loop HBCD. 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 HBCD and EFH. Consider this loop. This H, yeah, from here like this. Consider this loop and apply Kirchhoff voltage law. Apply Kirchhoff voltage law. So, what the Kirchhoff voltage law apply here? We have two voltage sources and this resistor here. So, right, say here, I have I1 is a current here, say, okay, and say I have I2, so current I1 here and current I2 here. Because this is positive, so current is starting in this direction and this like this direction. And current here becomes I1 plus I2. Here current also I1 plus I2. Now write the voltage equation. So twice I1 is twice into I1, voltage drop. Twice I1, this is the opposite, minus 6, plus the same direction, so plus 2. Current is start like this, it is now opposite, so voltage becomes opposite. So this is minus 6 and this is plus 2. And then the current is opposite to this, so minus 3I2. So that is the equal to 0. Summation of all the voltages, applied voltages, this volt, if we start from here, this comes in the opposite direction. Current coming from this direction. So 6 volt, if it is starting from here, then this becomes anywhere. One must be positive, otherwise negative. So minus 6, then plus 2. And current is this, here is 2 into I drop, here current is opposite to this current. So this is 3I2. 3 into, because 3 resistance, so IR drop, potential. So this equation you can write twice I1 minus 3I2. Twice I1 minus 3I2. This is minus 4 equal to 4. So this becomes equation 1. And then loop ABHF. ABHF and EGA. ABHF. ABHF. This loop. Only one cell, this loop. Write the voltage law for this loop. You can write thrice 3 times I2 because here 3 and current I2. So this we are starting like this, current opposite. Or we take positive and 3I2 minus 2 because this is voltage opposite to current. Current going like this positive point. So we are taking here 3I2 minus 2 opposite to current and plus 5I1 plus 5I1 plus I2. Because current in this 5 ohm is I1 plus I2, this current coming here. So this voltage drop is say plus direction anti-clockwise, it takes a positive, clockwise a negative. And this is a opposite to this battery positive like this. So both IR drop must be opposite. So that is a 3I1, 3I2. Here the current is 3I2. 3I2 minus 2, and this current is opposite to this. So plus 5I1 plus I2, this current. So total voltage, this voltage and IR drop must be equal. So that is a 2 volt must be equal to IR drop. You can say the applied voltage 2 volt must be equal to IR drop. What IR drop? 3I2 plus 5I1 plus I2. You can use like this. The Kirchhoff voltage law. The applied voltage must be equal to the total IR drop. From this, you have one equation here and you have one equation 2. So you can solve this equation 1 and 2. Solving equation equation 1 and 2, you will get the value of I1 and I2. You will get I1 equal to I2. So that is, I1 is 1.23 ampere. I1 you know, and I2 is 0.52. I2 is minus 0.52 ampere. Means the direction of I2 comes opposite to that. So this gives the current. Terminal voltage is I1 plus I2 into 5. That is here. This is 5 ohm resistor. So current passing through this I1 plus I2. So what is the terminal voltage of this battery? Because this is internal resistance. So voltage terminal. We have EMF 6 volts. So what is the terminal voltage at these 2 points? That is I1 plus I2 into 5. So that you can calculate. And this value comes out to be 3.55. 3.55. So this is the terminal voltage answer, and I1 and I2 are given here. So this way, Kirchhoff voltage law is sufficient. Sometimes when you write mass equations, you take the complicated circuit analysis, mass equations, then you use the current equation also. That is, the current reaching and current leaving must be equal. So that way, we can solve the problems of this electrical measurements. Well, friends, I stop today here. Maybe next time we meet, I may start something, some other thing, some new thing. Thank you very much.